Okay, here we go. So here is a centroid problem, and we need to talk about how to solve it. So the idea is this. With this centroid, you have two shapes. You have a rectangle, right? That rectangle is going to be, one centroid shape, and then you have a triangle centroid shape that you're going to have to subtract to it. Now with this, everything is going to be with respect to the origin. The origin is right there. So when we talk about our distances, it has to be connected to that origin right there, okay? So let's talk about the formulas for these centroids. We have two different formulas. We have the centroid shape for a rectangle, and the rectangle will just be half of the base, so base divided by 2, right? And the y is going to be height divided by 2, okay? Now, we're only going to be doing the x for this problem, and you can do the same thing for the y. The formulas for shapes together, if you have a compound shape, is that you are going, so to get the x location of a whole shape, you're going to do the sum, right, that sigma, of our x times the area for each shape, okay, divided by the sum of our area, or areas, okay? Now what does that mean? That means we have to get the centroid location of each shape, right? And we're going to use these here. We're going to just do the x's, so we're going to get these here, right? We're going to get the areas of each shape. I got a rectangle and I got a triangle. Those will go there, okay? And then we are going to but we're going to make the area of the triangle, right? That area in the triangle here should be negative. We're going to subtract away. So when we talk about sums, the areas of the triangle will be a negative value, okay? Because it's cutting away from the centroid location. All right, so let's get started here. I'm going to tell you the key is you have to do something to keep everything in track and organized. So I strongly urge you to do some kind of table just so you can keep track of everything. All right? Okay, so first up, let's make up some numbers here from a quiz. So I'm going to say the base is 211. Actually, I'm going to do 210 because I want to do easy math. So 210, and let's say the height is 120. 120 there, okay? All right. So, another one. The centroid location of a triangle is always going to be a third of the way. I'll get into that after. All right, so let's do the rectangle first. The rectangle centroid location is just going to be half the base for x. So the centroid location, I'm going to do this as a rectangle. That's a positive. This will be the triangle. There's no third one, okay? So I'm going to do 210 divided by 2, and I get 105. That one's easy. Okay, I could do this one up here if you wanted to, even though we're not going to need it. But the y location would be 60, right? Because half of 120. All right, now, the triangle, the formula for the triangle is going to be a third. So if you have a right triangle, you'll see the equation, right? If you have a triangle like this, I don't know how that looks like a triangle. It doesn't look like a triangle at all. Let me try it better. So I got a triangle, looks like that, right? And I got a right angle. The x location will be a third, okay? A third of your base. So the base of that, ooh, that was really small, base divided by 3 from the right angle. Okay, so if you think about this right triangle here, okay, and here's my right angle, it's going to be a third of the way in. So we can figure that out, okay? But let me point something out first. Again, it's going to be with respect to the origin over there, okay? So don't just jump ahead and plug it in. Realize you're going to have to measure it from the origin. All right, so what do we got? The base of this triangle is half the base of the rectangle. So right away we know that the base of the triangle is 105. Okay? That divided by 3 all right, is going to give us 105 divided by 3, 35. Okay, so our centroid location will be, so the x for the triangle is going to go out this far, 210, but then come back 35. So it is going to be 210 minus 35. And the way I did that was I just did the base of the rectangle, and then I minused a third the base of the triangle. Okay, so 210 minus 35. So 210 minus 35 gets me 175. So I have 175 is the x location of that. All right, how about areas? All right, so my area of my rectangle is just base times height. So I have 210 times 120, 210 times 120, and I get 200. 25,200. So 25,200. All right, what about my area of my triangle? Area of the triangle is going to be 1/2 my base times height. My base is going to be 105, right? 105. My height is going to be half of 120, so 60. So I get 1/2 times 105 times 60. And I get 3150. Okay. So I want to point something out, though. So we do 3150, but what did I say before? This is going to be a negative area because it's cutting away. So I got to make sure that value is negative. Okay? All right. Let's do the XA. So I'm just going to do X times A, 105 times 25, 200. So 105 times 25, 200. And I get a really big number, 2646000. 2,646,000. Okay, 175 times 3150, but I'm going to make it a negative 3150. So 175 times a negative 3150, and I get a negative as well, 551250. Does that look right? 175 times, yeah, something's not looking right. Oh, I got my number, I got my commas wrong. 5512, yeah, I don't have a comma there. Sorry about that. Okay. So now what we have to do is get our sums. We have to sum them up down below. All right, we're getting our sums down here. So our first number is going to be 25,200 minus 3,150. So 25200 minus 3150, and I get 22050. 22050. Okay. And now I'm going to do the 2,646,000 minus the 551,250. So 2646000 minus 551250, and I get 2,094,750. Okay. So far we have the sums of the area and the sums of the x times the area. Our final step to get our centroid location in the x will be just doing the sum of the x times the area divided by sums of the area. So I have 209, I'm sorry if this is hard to read, let me do a different color. 2094750 divided by 22050. 2094750 divided by 22050. And I get an answer of 95. That's a pretty clean 95 right there. Okay, so what did that mean? That means the x location for this. If there was no triangle here to separate or to subtract, the x location would be right there in the middle, right? However, because this cuts away, and that would have been in the middle, would have been 105. Because that triangle is cutting away, our centroid location, at least in the x direction, will be around 95. So it'll just be slightly in, which does make sense. Okay, thanks for watching.